Hello everyone. Today we will solve some problems. We will study some solving methods of problems in algebra, college algebra, and we will study greatest common divisor, and we will find the greatest common divisor using Euclidean algorithm. Then we will divide polynomials using synthetic division, and we will also study the least common multiple. So let's start. Okay, let's start. Our first example is finding the greatest common denominator of 20, and let me write, let it be 45. And we should find the greatest common denominator of 20 and 45 using the Euclidean algorithm. The greatest common denominator is the number, the largest number that both divide 20 and 45 evenly. What should we do? Firstly, we should write the largest number, 45, and equal it to the smaller number, 20, times some number. Let it be C plus R. This is the remainder. So here C is the number that how many times 20 is in 45. So it's clear that 45 is equal to 20 times 2 plus 5. So we will continue this process. Here the remainder is 5, and we will continue this process until the remainder is 0. So here we will write down this in this position, okay? And we will write down the remainder in the position of 20. So 20 is equal to 5 times some number Q plus R. And it's clearly seen that 20 is equal to 5 times 4 plus 0. Yes, here we got that the remainder is 0, and we said that in the beginning of the example we will continue this process until the remainder is 0. So we got that here the remainder is 0. Our answer is the last remainder, the remainder before this, okay? The last remainder is 5. So our result is 5. And let's try another example, more complicated, and this was simple. And let's try out the greatest common divisor of 1,701 and 3,768. What we should do, we should write down this. The greatest number is equal to the smaller number times some factor plus remainder, and it's obvious that here C is 2, 1,701 is 20 times 2 is equal to plus remainder. 366 is equal to 300,768. And if we continue this process, the remainder is not 0. We will continue this process until the remainder is equal to 0. And this is our first remainder. Let's continue. And this is equal to 366 times 4 plus 237. The remainder is not equal to 0 again. It means that we should continue this process. So 366 is equal to the remainder times 1 plus 129. Okay, the remainder is again not equal to 0. We will continue this process. 129 times 1 plus 108, and we will continue. So the remainder is 21 here, and again 108 is equal to 21 times 5 plus 3. So the remainder is 3, and I guess this is our final step. 21 is equal to 3 times 7 plus 0. So you see the remainder is 0. In the beginning of this tutorial, I said that we will continue this process until the remainder is 0. And if the remainder is 0, our result is the previous remainder. If we back to the previous remainder, we see that it's equal to 3. Now let's find the greatest common divisor of 3 numbers. Firstly, we should do the prime factorization. What is prime factorization? 3 and 11. All the factors should be prime numbers. What are prime numbers? Prime numbers, as I mentioned in my video tutorial about divisibility, prime numbers are the numbers that has factors only 1 and there itself. And the prime factorization is 11. The prime factorization is 44 is 4 and 11. So let's find the greatest common divisor. We should find the number which is take part in all 3 prime factorization of these numbers. So look, 3 is not here, also not 3. So 3 is not included. 11. Yes, 11 is here, 11 is here, and 11 is here. Let's write down 11, and 4 is only here, not 4. Okay, 4 is not included, so the greatest common divisor is only 11. Let's try out another example. Find the greatest common divisor of 35, 182, and 266. And let's do prime factorization of all 3 numbers. Here is 5 times 7. They both are prime numbers. Here is 2. 91, and if we do prime factorization to 91, we get 7 and 13, and here we get 2, 133, and it's equal to 7 times 19. So let's find out. 5 here, no 5, no 5. So 5 is not. 7, 7, 7. Let's write down 7. And here 2, no 2, 2 here, but it is not take part here. So 2 also not. 13, no 13, no 13. Okay, 19, no 19, no 19. So the greatest common divisor of these three numbers is only 7. And next example is synthetic division. Here we have two polynomials and we should divide it. Our numerator is x cubed minus 2 times x squared minus 5 times x plus 6, and we should divide it by x minus 3. So what should we do here? Let me write. Put here the coefficients of the numerator. They are, the coefficient of x cubed is 1, the coefficient is minus 2, minus 5, and 6. What we should write down here, we should find the zero of denominator. What does it mean? It means that x minus 3 is equal to 0, x is equal to 3. We should write down 3 here. And firstly, we should write again the first coefficient here. This is 3, let me write 3 times 1. Let's write here 3 times 1 is equal to 3. If we add both these sides, we get 1. And 3 times 1 is equal to 3 again. And if we add these parts, we get minus 2, and 3 times minus 2 is equal to minus 6, and the sum of positive and negative 6 is equal to 0. So we got that the last coefficient is 0. If you don't get 0 here, it means that x minus 3 is not a factor. You should got 0 here. Just keep it in mind. So what is the result? If we divide x cubed by x, we get x squared. So the coefficient of x squared is 1, x squared. Then the coefficient of x is also 1, positive 1, 1 times x. And our third is minus 2. We get that x squared plus x minus 2 is our final result. And let's try out another example. X cubed plus 5 times x squared plus 7 times x plus 2 divided by x plus 2. So What is the root of x plus 2? Is minus 2, yes? X plus 2 is equal to 0, x is equal to minus 2. And we write down the coefficients here. 1, positive 5, positive 7, and positive 2. We should write down 1 here and multiply it by minus 2. Minus 2 times 1 is equal minus 2. If we add these two numbers, we will get 3. Minus 2 times 3 is equal to minus 6. And 7 plus minus 6 is equal to 1. And minus 2 times 1 is equal to minus 2. If we add these two numbers, we will get 0. Again, the last number is 0. If we get 0 here, it means that x plus 2 is the factor of this number, this polynomial. This polynomial can be divided by x plus 2 if it is 0. So our result is x squared plus 3 times x plus 1. So if we divide this polynomial by x plus 2, we will get this answer. And let's try out another example. 3 times x squared plus 7 times x minus 20 divide by x plus 5. So x plus 5 is equal to 0, x is equal to minus 5. And here we should write down minus 5 here, and the coefficients 3, positive 7, and negative 20. And again we write here minus 5 times 3 is equal to minus 15. If we add these two numbers, we will get minus 8. And also minus 5 times minus 8 is equal to positive 40. If we add these numbers, we will get 20. You know, this is not equal to 0, but we said that in our previous video, in previous example, if and the last number is 0, it means that this polynomial is divisible by x plus 5. But here we do not get 0, it's 20. It means that our polynomial can't be divided by x plus 5. But we will continue this process. Nevertheless, the last number is not equal to 0. Let's continue. If we divide 3 times x squared by x, we will get 3 times x minus 8 plus 20 divided by x plus 5. So this is the remainder. If we divide this polynomial by x plus 5, we will get this result. So example, 7 times x cubed plus 6 times x minus 8 divided by x minus 4. So 4, positive 4 is, it should be right down here. 4, and the coefficients 7. What is the coefficient of x squared? It is 0. Yes, here we have 0 times x squared. You know, we should write down here 0, positive 6, and negative 8. And 4 times 7 is 28. We will get 28 here. 4 times 28 is equal times 120, and if we add these numbers we will get 118. 4 times 118 is equal to 4 times 72, and if we add these numbers we will get here 4 times 64. So our result, our final number is not equal to 0. So it means that the polynomial is this polynomial cannot be divided by x minus 4 without remainder. And if we continue this process we will get that 7 times x squared plus 28 times x plus 118 plus 464 divided by x minus 4. So this is our result. And another example, 3 times x to the 4 minus 5 times x squared plus 6 divided by x minus 3. Here we write 2 and the coefficients 3. As you know, the coefficient of x cubed is 0, minus 5, the coefficient of x squared, and positive 6. Let's write this here again. 2 times 3 is equal to 6. We write down here 6. 2 times 6 is equal to 11. If we add these two numbers, we will get 7. And 2 times 7 is equal to 14. And if we add, sorry, here we missed 0. We missed 0. 0 times x cubed and 0 times x. Okay, 14, it should be right down here. Okay, and this is 14, and 2 times 14 is equal to, let me write, 28. Okay, 6 plus 28 is equal to 44. So what is our result? As you see, the final number is not equal to 0, so we will have remainder. If we divide x to the 4 by ax, we will get 3 times x cubed plus 6 times x squared plus 7 times x plus 14 plus 34 divided by x minus 2. So this is our final result again. And in this part we will study the least common multiple, how to find the least common multiples of 2 or 3 numbers using prime factorization again. And let's find out the multiples of 3. It is 3, let me write down like that, 3, 6, 9, 12, 15, and etc. The multiples of 4 are 4, 8, 12, 16, 20, let me write here, 18, 21, 24, and here 20, 24, 28, and etc. So let's find the common multiples. You know, here 12 is the common multiple. Also 24 is common multiple of 3 and 4. But we should find out the least common multiple. Between 12 and 14, the least multiple is 12. So the least common multiple of 3 and 4 is equal to 12. And here is the final example. The least common multiple of 12, 15 and 20. In order to find, we first should prime factorizate these three numbers. So the prime factorization of 12 is 2, 2 and 3. The prime factors of 15 are, let me write it here, not 3, just 2, 3 and 5. And the prime factors of 20 are 5, 2 and 2. All these numbers, you know, are prime numbers, which factors is just 1 and there itself. If we want to find out the least common multiple, we should write the numbers. How many 2's is used here? 2 2's. How many 5? 1 5. And how many 3's? 2 3's. What is the LCM? Let me write here. How many? The most of 2's are 2 2's here, no 2's, and 2 2's here. 2 2. And how many 3's? The most of 3's is 1 1 and nothing. 1 3. And the most of 5 is 5, just 1 1 5, and it is equal to 4 20 60. Yes, great. And let's find out the LCM of 4 numbers. What should we do? Again, prime factorization. 2 2 and 2. The prime factorization of 10 is 2 and 5. This is 2 2 and 3. The prime factorization of 15 is 3 and 5. So here, you know, 3 2 is takes part. Here 1 2 2 2 and 0 2. So the most of 2 is here 3 2. And what about 5? No 5 1 5, no 5 1 5. So the most of 5 is 1 5, and the most of 3 no 3 no 3 1 3 and 1 3. The most of 3 is 1, and again 5. So 8 40 and 120. So this is the tutorial of LCM. I guess it's obvious to you, but if some unclear part is remained, please let me know by writing down comments. Thank you. See you in our next video.